So, dear students, I'm going to start with this new problem based on the IRDO's problem, the specialist in physics. So, one of the problem was there where this was the problems which students had a demand here. What student demanded actually, sorry for that, uh, that acceleration, the first car starting with first acceleration. So that is meter per second square. So it's not written properly. A is equal to 5 meter per second square there. And starting from the rest uniformly, and finally de-accelerating at same speed and that same rate it is coming up. That is velocity with respect to time and coming to the rest. So total time of motion is 25 seconds. Average speed during this is 20 milliseconds. The average speed is 20 meter per second, not millisecond, sorry. It is 20 meter per second. How does the particle move uniformly? Now, this they have solved. This Isdo he has solved. The solution gives you the direct value where something tau minus delta t. He is considering the tau minus delta t formula, and upon this, that is the tau, the total time minus the average. Like using this formula, he has solved, but it is not understood properly. So, using the graphical method, I'll be solving this one. Okay. So let's begin here. So first I'll erase whatever this part. Rather than going with the formula, let's begin with the regular way. So first part is that I'm doing a graph. I'm taking a graph directly over here. It will take me to draw. So zero, it is starting from rest. If you'll observe, this is the rest. Starting from the rest, velocity is increasing, increasing. This is the distance that is phi t. Now phi t velocity is phi times t. T is the time. Velocity will be here. Total time is 25 seconds. Total time is 25. This is the velocity increases. First acceleration with 5 meter per seconds. Okay. Acceleration 5 meter per second square, sorry, starting from the rest. After that, what will be then uniformly, then it is moving uniformly. This is the uniform motion over here. Then we will assume that as x here. Uniform motion, the distance. Prime time taken for the uniform motion, we don't know. That we will be assuming as x here, and now it is deaccelerating or deceleration is that coming to rest here, from it is coming to rest here. So at this point we'll assume after time t is coming to the rest. So let's begin with the formulas. This is the basic graph you'll be having. So you are getting this one rectangle here, one triangle here, one triangle here, one rectangle here, and again one triangle. So the areas is going to give you the final answer. The areas will be giving the final answer. How long, the total time period. Okay, let's begin. So this is, I'm taking one the diagram once again for the confirmation. So let's start with this. So let t be the time of accelerated motion. Right? We will assume this t as time of accelerated motion. V be the velocity. Now this is v will be the velocity. T will be of during the uniform motion. Now here v is equal to 5t. V will be equal to phi t as final velocity of accelerated motion of velocity. Velocity is due uniform motion, so no change in velocity. Just I am taking velocity is equal to 5 times velocity of time. The acceleration is v velocity upon time. So I am taking cross multiplying acceleration to v upon t. Here because you accelerated motion is uniform velocity during uniform motion. So just velocity will be 5t. Got it? Now next part goes. So total. Now what will be the total time? So total time is given by, that will be given as 25 seconds. Total time is 25 seconds. That is given in our question only. So we'll have 2t plus x is equal to 25. So x will be here 2t. This t plus this t. Total time. So time here to here. That is the total time. Here to here. This is the total time. Right? So 2t plus x is equal to 25. So x is equal to 25 minus 2t. Got it? So next part, if now total displacement. Now what is the total displacement we are having? Displacement, you know, it is a vector quantity as usual, is area under the curve. So which type of area? That will be area under VT graph. Remember, displacement is area under the VT graph. What are the areas? We will have this. Just we will work with various colors. I'll highlight various colors. So first, this will be the one of the areas now. Consider this. This will be your one of the areas. But what you have to consider over here? First section, first part. So if you'll observe this beauty graph, Then second, this will be area of triangle. Now this will be 1 half into 5t, 1 half. It is 1 by 2. Here also it is 1 by 2. So it will be 1 half into 5t into t. So 1 by 2 into 5t into t. That is area of triangle, 1 half base into height. So total plus 5t, that will be rectangle now. Rectangle 5t into actually 1 half base into height. So how we are finding this? 5t into t. This is height. This is base for this triangle. You consider. Now let's go for this rectangle. If you consider this second part, rectangle, this rectangle part, second part. So breadth into breadth into height. That will be your rectangle part. This is going to give you the rectangle part. So it is what it is. Exact. This is what we are having here. So that will be 5t. That is the height or width of the rectangle, and this is the length of the rectangle. So length into width or breadth of the rectangle. So we got this area 5t into 25 minus 2t. Got this? Why? How I'm getting 25 minus 2t? This is x. X is nothing but 25 minus 2t. So this is what I'm substituting here. So x is 25 plus 1 half now. 1 half into 5t as usual. Same. The height of the, that is 5t. Height of the triangle 5t multiplied by the base, that is t. So as a result, what final answer? This is how we got the formula. Now just I'll clear this. So on solving this, what you'll be getting here? Just I'll make this proper notes to just because it is appearing like 2, so it is not properly mentioned. Sorry for that. So if let's go with this black color, I'll have this. It is 1 upon 2 into 5t. So this is what the area of triangle we are having. This is the area of rectangle what we are having. And again 1 half base into height. This is what the area of third triangle. So one triangle, second rectangle, and third triangle. Okay. So if this is what we got, the total displacement. Now what is the formula for average velocity? Average velocity is total displacement upon total time. Total displacement divided by total time. So as a result, just plugging in the values. Total time is 25 there. Average velocity is 20, that is given in a question only. So average velocity 20, 1 half, we substituted 5t into t, 5t into 25 minus 2t, 1 half, 5t multiplied by t. So this is on solving this cross multiply, it is 500, 5t square, 1 half, 1 half, 5t square here. This is 1 half 5t square, 1 half. Okay, I'm getting 5t square upon 2 plus this is again 5t square upon 2. So that becomes 5t square there. 5t square means that is 10t square upon 2. So that becomes 5t square, right? 5t square there. So that is what you got 5t square. On solving, you will be getting here what is the minus 10t square, 25t minus 20t. So how much you will be getting? 10t square, and 25 to 5 is 125t. Right? So 5t into 2t, that is 10t square, which is 25t. Divide 25 into 20. If you cross multiply this, you will be getting 500 there. So next step, just solving this quadratic equation as usual. You will be getting here, you are getting two values here. Remember, t, that will be t minus 20 and t minus 5. But the total time, remember, t minus total time, you cannot get 20 here. Because already the total time given is 25 seconds. So it cannot happen that this small t can be 20, 20, 20. So we are discarding, we are not t equals 20, discarding t equals 20 value. We are discarding this value. So assume this value, t equals to 5, according to the given conditions. So when t equals to 5, what is the final? If particle is moving uniformly, so the particle moved uniformly for 25 minus 2t, that is equal to 15 seconds. Plugging in the values for this. Right? So this is the final answer what you got. That is 15 seconds here. So this is much easy method for the convenience. From the graph, it is more convenient to get the idea. Okay, thank you.